Welcome to the 11th lecture, or you can say our session of survey practice 2. So today we are going to try to determine the horizontal distance with the help of the tachymetric survey. That is your determination of horizontal distance by horizontal site. This will be a little bit similar to the previous experiment that how we found out the stadia constants. Same way this will be. Right, how it will be, let's see here. First we'll see the procedure for it. Set up the instrument at a point A. You set up an instrument somewhere and say that a point as A. Level it accurately, both plate level as well as the altitude bubble, both you have to level it. Make the vertical to read 0 and clamp it so that it should be parallel to the ground and it should be along the line of collimation, should be parallel to the ground. Right, keep the staff at unknown distance. The distance between the staff and the instrument should not be known, because we want to calculate the horizontal distance itself, right? So if you know that distance, then what is the use of doing the experiment? So keep the staff at such a distance that you don't know the distance from your station point, right? Say the distance between at a point B, at an unknown distance point B. You have to set up the staff and take the reading, right, corresponding to the both top and the bottom hairs. Difference between the two readings will be the staff intercept S1. Okay, it will be S1. It is what is it is? It is a difference between the top and the upper stadia hairs. No center crosshair that we are used to do in the theodolite. We used to use, or we used to use in the dumpy level. We are going to use only here upper and the lower stadia hairs. Understanding what I am saying? So that you have to do. If you want to calculate for more number of values, you can go on doing that for further points, that is C, D and E also, right? Now once you have calculated the the S, right, what are we going to do? And we also know what is constants are. We are determined in the previous class. K will be always, it will be 100. Okay, I am not saying every time, but sometimes it might change depending upon the instrument manufacturer, but most of the times it is K is equal to 100 and C will be your 0. That is your additive constant. Now with the help of the formula, right, to calculate the distance d1, okay, you have a formula called d1 is equal to K into S1 plus C. What is K? K is 100 into whatever the staff intercept it is there, multiplying with that, plus C. C is 0. So you will find out the distance. You will get a distance, unknown distance d1 from the instrument A to the staff station. You will see here. Similarly, selecting the different staff stations C and D, knowing the staff intercepts S2, S3 constant, calculate the unknown distance between D2 and D3. In this case, it is very easy. The procedure is very easy. To do also, it is very easy. But remembering the formulas is very important. Without the formulas, you can't solve this. You can't do the procedures, right? You can't calculate the distances and constants. So it is very important to go for the. You should know the formulas. In the case of this constant head stadia constant, and as well as for this calculating the horizontal side. See, what we have done, we have to set up the instrument at a point somewhere A. Then we have kept the staffs at 3 different unknown points, right? and we have bisected them, right? So we got this. Once we bisected, we read the readings, top and the bottom cross stadia hairs. It is called not crosshair, it is called a stadia hairs. Then at the staff 2, that is right at first station, that is B, you got S1 as a staff intercept. At C you got S2, and at D you got S3. Somewhere at a distance D1, D2 and D3. We don't know this distance. We have to calculate the D1, D2 and D3 now. Right? So with the help of this formula, that is Ks1 plus C, Ks2 plus C, and Ks, you know the K, you know the C value, it will be constants, right? The value which will change will be S1, S2 and S3. As we know, as the distance between the station increases, right, the S1 value will also increase, right? So that gives you a horizontal distance. Okay, that gives you a horizontal distance. So that this is how we calculate the horizontal distance with the help of the tachymetry.